So, hello, we are finishing our notes on fundamental theorem of calculus. We are now on this page saying it says notes, accumulation, and FTC. So this first statement gives us some information right here. And what it's saying is the derivative of f, capital F, is little f, which also means the antiderivative of little f is going to be capital F of some form. So let's take a look at this first one. So in our first one, we have the definite integral from a to a of little f of t. If we wanted to write that in our definite integral evaluation form, we can. We know that this is 0 because there is no area from a to a. There's no width, so there's no area. But this is also the same as f of a minus f of a. So that also gives me 0. Capital F, of course, being the antiderivative of little f. So when this is evaluated, the definite integral gives us 0. Okay. Next one, number 2. For this definite integral, what we're going to have is the antiderivative of f, and we're going to have that from a to b, which is going to be capital F of the top bound minus capital F of the bottom bound. So that is just our fundamental theorem of calculus that we've been using to evaluate definite integrals, and we would end up with a number. Next, we have added a variable. So a is a constant, but x is a variable. So this is going to give me, again, capital F of t evaluated from a to x, which is going to be capital F of x minus capital F of a. Now, this is going to give me a function, okay? This is the function with x plugged in, take away this constant. So this is going to be a function, whereas the other ones are all going to be numbers. So this one's a number, and obviously 0 is a number. So let's look at these problems that we need to address. Write a sentence to answer each of these questions. So number 1, h of t is a rate of change. Okay, so that's kind of like our derivative of the height. And this height is of a conical pile of sand measured in feet per hour. So what does the definite integral from 0 to 5 of h of t represent? Well, I kind of rewrote it a little bit as 0 to 5 of the rate of change of h with respect to time, which means this is going to be the height at 5, take away the height at 0. So now I need to write in words. So I'm answering the question in a sentence. What does this represent? And I need to include units. So this represents h of 5 minus h of 0. So basically what it represents is the change in height and that is measured in feet between, and our units for time are hours, hour 0, and hour 5. So, number 2, I would like for you to try number 2, please. Please pause the video here to complete number 2. Here is my answer, that this is the change in position, which is measured in feet, between second 3 and second 10. Please pause the video here if you need to write anything else down. Next one I would like for you to do now is number 3, please. So please pause the video here and complete number 3. Here's my answer to number 3. It is the change in the number of bacteria between hour 6 and hour 2. Please pause the video here if you need to write down any corrections. Number 4. V of t is the velocity of a particle moving along the x-axis at time t, and the position, we're calling that x of t, is 5 at time t equals 2. Part A is asking us to write an integral expression, so that's going to have an integral in it, and it's just an expression, there's no equal sign, that represents the position of the particle at time t equals 10. And again, we know the position of the particle at time t equals 2 is going to be 5. So I would like you to try part A. I'm writing in highlighter. Sorry about that. Okay, part A. So go ahead and pause the video here to complete number 4A. Here is my solution to part A. My final answer to part A is this. The definite integral from 2 to 5 of v of t plus 5. So you are welcome to jump to that, because what that means is this is the change in position from time is 2 to time is 10, and we already knew that the object was located at position 5 at time 2. And if that doesn't make sense to you, then jump over here to the work where I'm saying, okay, using our definite integral, our fundamental theorem of calculus, we know the antiderivative of velocity is going to give me position. So I'll have position at 10 minus position at 2. I know what position at 2 was. That was given to me, that at time 2, my position is 5. And then I'm solving for x of 10, because that gives me my position of the particle at time 10. So now that we've done that, we now should be able to do part B. Actually, part B has nothing to do with that. I don't know why I suggested that. So if you could do part B now and write the integral expression for the total distance traveled. Please pause the video here to complete part B. And part B is up in blue. So all I needed to do was make sure I was taking the definite integral of the absolute value of v of t. Moving on to number 5, I would like, big surprise, I would like you to do number 5. So please pause the video here to complete number 5. Here is my answer for my rabbit population in 2007, the definite integral of p of t from 0 to 2 plus 100. If you have any questions about that, please pause the video here to complete number 5. Moving on to the next page. Now, these are some examples of actual multiple choice questions, and they're all sort of relating to all of the things that we've been doing in this entire packet that we've had for notes. So starting with number 23, it's a non-calculator section. I would like for you to do this. I believe this is like worksheet number 2 if you have a question about it. So please pause the video here to answer number 23. So my answer for this one is E. My work is over on the right. If you have any questions, please pause the video here to write down my solution that's in the corner. Moving on to the next set, what we have now is we have calculator questions. So if you have not done so, please get your calculator out, and if you need to pause the video until you have your calculator out, that is fine. Go ahead and pause the video here. I'm going to go ahead and get my calculator out. So we have the rate of change of the altitude. So this is a rate of change, which means it's a derivative. So I have a derivative. And here's my domain, 0 to 8, which is the following expression gives the change in altitude of the balloon during the time the altitude is decreasing. So decreasing, how does that relate to my derivative? My function is decreasing, my derivative better be negative. So I'm looking for where is my derivative negative. Now my derivative is this r. So I'm going to use my calculator to figure out where this thing is negative. So grabbing my calculator, I'm going to go into y equals, and I'm going to key in my function. Oh good, old school. And I'm going to change my window so that I'm looking in the domain of 0 to 8, because that's all that I care about. And all I really care about is whether my derivative is positive or negative. So I'm going to squish my window just to go -4 to 4. I just randomly picked that. I could go -1 to 1. The key is I really want to look around when y is 0. So I'm going to graph that. And here is my rate of change, or my derivative. And so I am looking for, again, my function is decreasing where my derivative is negative. My derivative is negative down here. Okay, I'm circling it. That's where my derivative is negative. So what I need to do now is figure out, well, where is that? So I need to identify this little point right there, and I'm going to do that by doing second calc, and I'm going to do a 0, and I need a left bound. Where am I? X is 4. That's not good. Left bound, so I need to be on the left side. There we go. My y is positive. I hit enter. I arrow over and make sure my y is negative. I hit enter, and those two values are pretty close, so it doesn't really matter what I guess. So I know that my derivative starts to become negative at 1.571. So looking at these options here, I can eliminate all these options that don't have that value as a lower bound. So I've got rid of these. Now, if I want to know the change in the altitude during this time, the question is, am I finding the antiderivative of r of t, or am I finding the antiderivative of r prime of t? Because they both have the same bounds. I'm not going to find that other bound because this is multiple choice, so I can only assume that over here that value is x is 3.514. So question is, which one of these is going to give me my change in altitude? The one that's going to give me my change in altitude is A, because this is a derivative that is the rate of change of the altitude. So when I take its antiderivative, it will give me the altitude, or the change in altitude in this particular problem. 91, again, calculator question. So we have a particle moving along the x-axis. Its acceleration is given by this guy. If the velocity of the particle is 2 at time t is 1, so v of 1 is equal to 2, then the velocity of the particle at time t equals 2 is what? So this one should look a lot like what we were just doing. So I'd like you to write the expression, please, of the velocity of the particle at time 2. Please write that expression. So please pause the video here to write the expression down. Here is my expression. So v of 2 is going to be equal to the definite integral from 1 to 2 of a of t. So that's the change in my velocity from time 1 to 2. And then I'm adding 2 because that is my velocity at time 1. So at this point, I need to actually evaluate this, and I can evaluate it with my calculator. I know what a of t is, and that is right here. And I'm going to plug that in right here and key this all into my calculator and ask it the answer. So here I'm going to get out of this because I want to be where I can add, subtract, multiply, and divide. And I'm trying to do a definite integral, which is math, int. There we go, number 9. I'm old school. If you're new school, I think you can deal with it. Move my calculator a little bit so I can see my screen over here where I wrote my work. So I am doing a of t, which is natural log of, extra parenthesis, 1 plus 2 raised to the t, and I'm going to use x, and the comma, I think it is 1 comma 2 comma x. I think that's right. Nope, I have that backwards. So this should be x comma 1 comma 2. Sorry, I can't remember my old school calculator. So we have, this is just the definite integral. So that really is just the very first part. That's my definite integral from 1 to 2 of a of t. I need to add 2 to that to actually figure out my velocity at time 2. Now that I have that, I can go ahead and decide which is my answer. Looks like that answer is E. So finally, we're on to 92. And 92 is g is this function here, which is the definite integral from 0 to x of sine of t squared dt. And I'm just looking right here on which of the following intervals is g decreasing. Okay, I see g decreasing. That means my derivative is negative. Okay, so if g is the antiderivative of sine of t squared, then you should be able to write an expression for the derivative g prime. So please go ahead, and what I'd like you to write down is g prime of x is equal to fill in the blank. So pause the video here to write down that derivative. So here's my derivative written in blue, and it's the sine of x squared. And I do have times 1, the derivative of the inside is a 1. So now what I need to know is where is this thing where is this thing negative, because this is my derivative. So please pause the video here, use your calculator, make sure you're in radian mode, and go ahead and answer this question, please. So I have my answer is D. I have my graph of sine of x squared on the graphing calculator, and I found the beginning x value where this starts to become a negative value, and that value for x was 1.772, and so the only interval that starts at 1.772 is the one I have highlighted. And again, because it's multiple choice, I'm not going to go ahead and find that other 0, although I could. And this concludes this packet. I hope you have enjoyed our calculus time together, and have a wonderful day.